This might surprise you, but there are actually active volcanoes in Norway. And in fact, one of these active volcanoes has a populated settlement built right on top of one of its lava flows, which is in place sometime in the last 4,200 years. Now, I am not talking about mainland Norway, but rather the northernmost active volcano on the planet. As one of the only two active volcanoes situated north of the Arctic Circle, what I am referring to is the Beerenberg Volcano on the island of Jan Mayen. Located 1,155 kilometers northwest of the city of Trondheim, Jan Mayen is a mostly long and thin island absolutely covered in young lava flows. In fact, 30.3% of its land surface, totaling 114.41 square kilometers, is covered by lava flows in place during the Holocene epoch, dating since 9700 BCE. The settlement in question that houses the 18 people that inhabit the island from time to time all live in Oloken City, situated here. If you are wondering, here's a scientific paper's interpretation on the general level of volcanic hazard that settlement statistically faces in the long term. Yet, while there is a ridge of young-looking lava flows on Jan Mayen southwest, to the northeast is where all of the historical eruptions have taken place surrounding the edifice of the glacier-covered Beerenberg stratovolcano. Rising to an altitude of 2,197 meters or 7,208 feet, while Beerenberg's summit area does indeed contain Holocene lava flows, its historical eruptions have taken place at the very edge of its edifice near the shoreline, erupting in 1732, 1818, 1851, 1970, 1973, and 1985. The 1732 eruption was its most explosive in recorded history, mainly due to the interaction of rising magma encountering ocean water, forming the now mostly destroyed tuff cone known as Akॼar. Due to that eruption, which reached the volcanic explosivity index of a 4, tephra deposits even a full 5 miles or 8 kilometers away still reached a full 30 centimeters or 1 foot thick in some spots. While that eruption was a violent surge sand one, the other historical eruptions involved lava flows in predominantly Strombolian eruptions which created new land through lava deltas. But looking at this strange island, you might be wondering why exactly it has such a strange shape. The answer relates to the broader tectonic setting that the Beerenberg volcanic complex, which yes, comprises the entire island, is situated in. To the north of Jan Mayen, there is a transform fault boundary known as the Jan Mayen fracture zone. This straddles two sections of a mid-ocean ridge where to the north it's known as the Mons Ridge, where the crust is slowly spreading apart, likely due in part to a regional hotspot. This mantle plume thus caused magma to rise in a natural weak lineament of the crust paralleling the nearby divergent plate boundary, causing resulting volcanism to occur along a narrow southwest to northeast trend. When thinking about the geologic history of this island, it's best to divide it into two segments. Despite its massive size and volume, it appears that the stratovolcano portion of Beerenberg forms second, utilizing a dominant pathway of partial melting that generated large volumes of basalt magma. Meanwhile, to the southwest, more evolved, varied, and older magmas erupted at a somewhat lower rate, ranging in composition from basalt to trachyte. Their more evolved compositional range, hence the occasional lava domes that have formed, suggests that this part of the island formed first. And indeed, studies agree with this assessment, with the first above sea level portion of Jan Mayen's volcanic edifice erupting 564,000 years ago. This likely created an isolated volcanic cone above the ocean surface and the Jan Mayen microcontinent. Further eruptions created additional closely spaced volcanic islands until presumably by 400,000 years ago, an interconnected platform of tephra and lava flows had formed on what is now the section of Jan Mayen just southwest of the edge of the glacier-covered edifice of the Beerenberg stratovolcano. Subsequent eruptions expanded the series of islands to the southwest, with the island having expanded to here by 350,000, 300,000, and 250,000 years ago. 200,000 years ago seemingly marks when the base of the stratovolcano edifice began to grow, with presumed Vulcanian and Strombolian eruptions. Subsequent eruptions occurred throughout the entirety of the island, albeit preferentially occurring on the growing stratovolcano. A mile-wide summit crater eventually formed at that stratovolcano's summit, and glaciers later carved away portions of its edifice. In the future, the most dangerous type of eruption will be from any just offshore vent due to the likelihood of substantial ash generation. Overall, eruptions seem to occur on Jan Mayen about once every 85 years. Two of its historical eruptions, specifically in 1973 and 1985, were preceded by at least one magnitude 5 or larger tectonic earthquake. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.